Jai Jagannath friends, we are continuing our study of real analysis and today's concept is function. A function A from set A to set B is a rule. A function F from set A to set B is a rule such that every element of set A is associated with a unique element of B. Remember friends, this unique word is very important. A function f from a set A to set B is a rule such that every element of set A is associated with a unique element of B. The function is a mapping from set A to set B. This is a rule. This is a map. This involves two sets A and B, and this set A is called domain, and set B is known as friends codomain. And let us take some examples. Example 1 is that so F is a mapping from R to R plus. R plus means the positive real numbers, where R is the set of real numbers and R plus is the set of positive real numbers. And the mapping is that friend fx is equal to x. We shall verify whether the rule defined here is a function or not. Let us say friend, what will be f5? f5 will be equal to 5 because fx is equal to x. And what will be f minus 5 friends? This will be equal to minus 5. But you see the mapping is from R to R plus. The domain is the set of real numbers and the codomain is the set of positive real numbers. But here the minus 5 is not an element of R plus. So it does not belong to the codomain. Hence, this f is not a function. Every element of A, friends, should connect to an unique element of set B. You see, if this is set A and this is B, and this is say A1, this is A2, and this is A3, there are various, say this is B1, B2, B3 and B4. All the elements must connect to the elements of set B. No point in the set A be left behind. Suppose friends, this is the condition. This is set A and this is set B. And suppose this is A1, this is A2 and this is A3 and this is B1, this is B2 and B3. And suppose this is friend, see, here the mapping f is a function because no point is left here in set A or the set of domain. But here A2 is left behind, and suppose this let be a function F4 and this connect to B3. Here A2 is left. A2 does not connect to any point in the set B. So this is not a function. See friends, any point in the set of codomain may be left behind, but not in the set of domain. And the points elements or points or elements, the points or elements of set A, elements of set A are called pre-images. This A1, A2, A3, etc. And the B1, B2, B3, the points of set B, elements of set B are called images. Let us draw some pictures, friend, to clarify the concept of function. This is set A, this is set B. This is A1, this is A2, this is A3, and this is B1, this is B2, and this is B3, this is B4. Let us draw another. Let this be F1, the mapping be F1, and another here. This is A1, this is A2, this is A3, this is B1, this is B2, this is B3. This is another mapping F2. Let us consider the third mapping. This is A1, A2, A3, and this is B1, B2, and B3, and B4, and this is A1, A2, A3, and this is B1 and B2. This A1 connects to B1. This is the image. B1 is the image of A1, and suppose A2 connects to B2 and A3 connects to B2. Suppose A1 connects to B1, A2 connects to B4, and there is another example, friends. This is A1, this is A2, this is A3, this is B1, B2. A1 connects to B2, A3 connects to B1. This is F3, this is F4, this is F5. Let us examine which are the functions and which are not functions. See, friend, here no images is left. Every pre-images have a but unique image here, different images. And see, friends, here also no one is left in set A. Here also in the set A, one is left. That's why this is not a, F3 is not a function. But F1 is a function. Although B3 point is left behind, this may be a function. F2 is also a function. Two pre-images can have one image, but suppose this is A1 and suppose this is A2 and suppose this is B1 and suppose this is B2. See, friends, this A1 and A2 can connect, but A1 cannot connect to B1 and B2. One pre-images cannot have two images. This is suppose F6. The F6 mapping is not a function. Pre-image cannot have two images, but two pre-images can have one image. We can consider one example. Suppose fx is equal to x square, friend. Then suppose this is 0, this is minus 1, this is 1, and this is 0, this is minus 1, and this is 1. These are two sets A and B, and the mapping is F. Then friend, what will be F minus 1? F minus 1 is equal to minus 1 square, it is given x square is equal to 1. So minus 1 will collect to 1. This means the image of minus 1 will be equal to 1. And what will be plus 1? What will be image of plus 1? F1 will be equal to also 1 square is equal to 1. This will also connect to 1. See, two pre-images having one image, and this 0 will have its image 0. No one of this set is left. The images, there may be some points left in the set of codomain, but here in the domain or in the set of pre-images, no point is left. Hence, this is a function where we observe that two pre-images have one image, but one pre-image cannot be two images. Here f6 is not a function. Similarly friends, this is also a function. F4 is a function because no one is left here, but everyone is connected and two pre-images can connect to 1. But this F5 is not a function. Why? Because A2, one pre-image is left without having an image. Hence F5 is not a function. In these diagrams, we explain what is a function and what is not a function. Can have the same functional value, but one pre-image cannot have two functional values. Thank you friends for watching this video.